Children, in this video, we are going to see some conversions like binary to decimal, octal to decimal, hexadecimal to decimal. So first of all, we will see binary to decimal. So for that, we need to take a variable s is equals to 0 initially, and then every time we have to perform this operation, which is s is equals to s into the base of the number which from which we have to convert to decimal. Initially it is 2 plus the integer value of the digit which has been extracted. So here initially what happens, initially we have got 1. So what is the initial value of 0? S, which is 0. So 0 into 2 plus 1 initially, which becomes 1. And next time we will be getting this value, which is now this s, which is 1 now, into the base plus 1. So now this part becomes 3. Next time this is 3 into 2 plus 0. Now this part becomes 6. And when we exclude this 0, it becomes 6 into 2 plus 0, which is 12. So now further, if we include this one, it becomes 12 into 2 plus 1, which is 25. Further, this is 25 into 2 plus 0, which is 50. And then it is 50 into 2 plus 0, which is 100. So now you can see that this part is 100 point, and now the remaining part, which is 101. So what we do the same method which you people have discussed in previous classes or in previous video. It is 1 into base to the power minus 1 plus 0 into base to the power minus 2 plus 1 into base to the power minus 3. So this is how we can convert binary to decimal. Children, in octal what we will do, in octal the same process will be repeated, but this time what will change? Only the base will change. So this time again we are considering a variable which is s, and initial value of s is 0. So every time you have to repeat this process, s is equals to s into 8 plus integer value of the extracted digit. So now here what happens, initially what happens, it is 0 into 8 plus 1 when we have extracted 1, which is 1. Next time it is 1 into 8 plus 4, which is 12. And then when we have extracted this one, it is 12 into 8 plus 4, which is 96 plus 4, which is again 100. And then plus this part is 5 into 8 to the power minus 1, which is 0.625. So the decimal equivalent becomes 100.625. So children, the same method we will be using for hexadecimal to decimal, and in that case the base will change and the base will become 16. Okay, now we are going to implement now this program, this concept in Java program. So see, the code goes like this. So what we need to do, Here we have taken one variable str, and along with we have taken one variable which is num. One more thing we need to take is we need to take the all the possible digits from binary number system to hexadecimal. So here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then it is A, B, C, D, E, F. So this we have taken for in order to represent a hexadecimal number. And now first of all, what we need to do, enter number, and here, so we have entered this number which is ss dot next line, and here along with this we will enter the base. So enter base. So here the base will become ss dot next int. Now children, for the base we need to declare one more variable which is base. So first of all, now what to do, what we need to do is, suppose the number is 11001000.101. So we need to extract the index of the decimal. So here we need to extract the index number of the decimal, which is actually this one, the index of this character literal. So for that we will be using the function, and that function is index of. So for the index of also we need one variable which is p, and here we must write str dot index of, and here we are placing so this is how we have got the index. And now we are going to convert that. So for that we need to just take this loop from 0 to less than p and I plus plus, and here what we need to do is just we need to write num is equals to num into the base plus v dot index of ch, and where this ch is str dot caret of I. So let us see that uh, the number is decimal number is this num. So first of all, let us check whether it works for the decimal part or not. So children, here we need to take scanner class, and now suppose the number is 11001000.101. So here the base is 2. So it's working, its decimal equivalent is 100. So it works, it is working for the whole number part. And now check for octal. So in case it is 144.5, so here the base is 8 this time, and it is 100 again, so it is working for that. And if it is 64 point capital A and its base is 16, again it is 100. So it's working for the for all format, whether it is binary to decimal or octal to decimal or hexadecimal to decimal. Now we have to write the code for the uh, fractional part. So for that we need a variable which is actually s, and that s is basically initially it is equivalent with the base. So s is equals to base. And now here what we need to do is we need to start a loop that will go from p plus 1 and up to the length of the string. And now here after what we need to do is we need to just write. So what we need to do is just we need to extract the character like this, and or digit like this, and then what we have to do is just, and then s is equals to s into base. And here we forgot to make it double type, so here it will be double, and here it is 1.0. So let us execute this part. So children, here it is not I but it is J. So if the binary equivalent is 11001000.101 and the base is 2, it is the decimal equivalent, which is 100.625. Check for octal. If it is 144.5 and this time the base is 8, so it is 100.625. And in a similar way, if we input a hexadecimal number, and here this time the base is 16, the decimal equivalent is 100.625 again. So you can check this for large numbers also. So let us see for a large number. So here you can see that I have taken a value which is hexadecimal number, which is 234.567, and if we convert this number to decimal, it is 564.337646484375. So let us, we are going to input this value. So here execute this, and then simply pass this value, and the base is 16, and now you can see that it is which is 56, just compare, it is 564.337646484375. So I hope you have understood this concept, and I hope you have enjoyed this video. Thanks for watching.